For this presentation, I'll be looking at the importance of urban tree diversity, but more specifically on the effectiveness of the 10-20-30 rule, a method used throughout the United States and in some places internationally for measuring urban tree diversity. As an introduction, I'll first be talking about the need for urban tree diversity before we can get into the specifics of the 10-20-30 rule. Urban trees provide several unique ecosystem services to cities. Ecosystem services are those direct and indirect benefits to human populations. Air filtration is one ecosystem service. It's the reduction in air pollution, which is a direct benefit from urban trees. It's an ecosystem service provided by a number of urban tree species that ultimately increases the quality of life or human health. Different species can make a difference, as urban trees with higher leaf surface area are more efficient at reducing air pollutants. Coniferous trees, for example, have higher leaf surface area, thus having higher capacity to filter the air. They also maintain their needles year-round, as opposed to deciduous trees, who lose their leaves in the fall. This is crucial because air quality is less in the winter months. So in considering the 10-20-30 rule, as we'll talk about a little bit later here, considering use of coniferous species as part of that method of urban tree diversity in climates that are colder or have longer winter seasons, such as like in Alaska. Studies have shown that there's an 85% decrease and a 70% decrease in air pollution with the presence of urban trees in parks and streets, respectively. In addition to air filtration, urban trees provide several other services. Microclimate regulation. Urban trees provide for cooler temperatures, energy savings, and a reduction of the heat island effect in cities. They also provide carbon sequestration. Different species of trees sequester CO2 at different levels. Some trees have the ability to store more CO2 efficiently. So in using the 10-20-30 rule, it might be adequate to select trees that are better for carbon sequestration and storage based on how much carbon is being emitted into the air in the specific city. They also regulate stormwater runoff and sewage treatment. Urban trees also provide a sense of well-being physically and psychologically to the people who live in the urban environment. Urban tree diversity also creates a resilience to environmental stresses such as climate change, urban tree pests, and urban tree disease. This is just a graphic out of an analysis that I looked at when they analyzed the urban tree diversity in Minneapolis, Minnesota in 2005. This is a breakdown obtained from the urban tree diversity analysis. As you can see, the benefits provided 36% to stormwater, 29% to aesthetics, 27% to energy savings, and only 3% in carbon dioxide reductions, and only 5% in the air quality. So, what is the 10-20-30 rule? Well, the 10-20-30 rule is a method of urban tree diversity to which the following rules apply. There should be no more than 10% of any single urban tree species within the jurisdiction or municipality. There shall be no more than 20% of any tree genus within the jurisdiction or municipality, and there shall be no more than 30% of any tree family within the jurisdiction or municipality. So what are the purposes of this rule? Implementation of this rule is to increase biological diversity of urban trees and to increase urban tree resilience. To prevent catastrophic losses from common urban tree pests, and disease, such as the Dutch elm diseases and the emerald ash borer, providing only a 10% species and a 20% genus and a 30% family, will likely reduce the effects of some of these diseases. Another purpose is to prevent loss from other stretches such as the climate change and extreme weather events. Certain trees are more susceptible to extreme weather events such as hurricanes or tornadoes or high wind events, and even some trees are susceptible to flooding if they cannot take too much water or are flood resilient trees. The last purpose is to provide ecological benefits to other urban plants and wildlife, and specifically such as suitable habitats. Urban street diversity and the 10-20-30 rule. Some of the studies I looked at how effective really is the 10-20-30 rule. In one study, authors sought to obtain inventories of urban street trees in 12 different cities in the eastern United States, which is the temperate zone. So that is one limitation to a lot of the studies, is that they are only done in the temperate zone. None are done in some of the places in the desert regions down in the southwest corner of the United States. Anyway, the purpose of this study is to discuss the potential benefits for the implementation of the 10-20-30 rule in order to create sustainable biodiverse urban forests and reduce economic and ecologic loss from urban tree pests, such as the emerald ash borer, the Asian longhorn beetle, and Dutch elm disease. In the study, they provide evidence and monetary evidence showing that there have been millions of dollars spent on major losses, or millions of dollars lost to trees that have been lost from the pest and disease. In addition, millions of more have been spent on prevention methods in spreading of these pests and diseases. In their findings, several of the cities surveyed actually would lose up to 50% of their urban street tree population due to a potential spread of these pests or diseases. This is because their diversity in their urban tree diversity was nowhere near the 10-20-30 rule. In some cases, 35% of their tree species or their diversity was one tree species. So a need to diversify many of these cities was observed. The authors also suggested that rules like the 10-20-30 rule can provide resilience to urban forest communities, but there are several considerations that have been overlooked. So here's the effectiveness of the 10-20-30 rule. There are limited studies showing evidence to support the level of effectiveness for the 10-20-30 rule on urban forest ecosystems. Some evidence to show the effectiveness of a diversified urban forest are: biologically similar species, genus, and families are often susceptible to the same stressors and same pests and same diseases. They also adapt the same and have the same resilience. The 10-20-30 rule is effective in maintaining a diverse urban tree community so that there are less genetically similar trees, so to prevent a catastrophic loss by illnesses or pests. Reduced health risks to human population due to the loss of over 100 million ash trees in the United States. From pest diseases, illness, weather events. Because of the loss of 100 million ash trees, nearly 20,000 deaths have occurred as a result of lower respiratory and cardiovascular disease, which I thought was a very interesting statistic. But the article does not provide how they exactly come to the conclusion that these 20,000 deaths were actually a direct result of the lowered amount of ash trees causing lower respiratory or cardiovascular disease. And the 10-20-30 rule creates a buffer against an overrepresentation of any single species, genus, or family. There are a few limitations to the 10-20-30 rule. Although there are several advantages to implementing the 10-20-30 rule, there are a few considerations to look at. Several common tree pests have the ability to attack more tree species other than just those it primarily attacks, meaning that although there's a slightly reduced risk of spreading a catastrophic disease, there is still a risk for tree loss from these pests and disease. Although the rule applied would bring an increase in tree diversity, the implementation of the 10-20-30 rule may replace current urban trees that are already better adapted to their current environment, and being replaced with those that are less successful or less adapted to that environment, leading to a greater loss in urban trees and actually making things much worse. Although several cities implement this rule throughout the United States and abroad, the 10-20-30 rule is still considered a rule of thumb, to which still lacks the amount of empirical evidence to fully support in the scientific community. There's also a lack of research in other regions around the United States and the world. Regionally, in different climates, this rule may not be as efficient or work as it is supposed to create more diversity, but also create more resilience. In some places it might be worse, such as desert regions in the American Southwest. Most studies have only been conducted in temperate climates. So from looking at the studies of the 10-20-30 rule and urban tree diversity, come to these conclusions. Urban tree diversity is important for several reasons, mainly the ecological services that it provides, aside from the fact that it may or may not control diseases and pests. The 10-20-30 rule would provide a much-needed urban tree diversity across many regions of the United States, resulting to an enhanced ecological services to those cities. The 10-20-30 rule has few limitations to consider, and further research is needed to fully implement it. It is effective in many aspects, but could be ineffective in others. And in mentioning the advantages of the 10-20-30 rule, aside from pest control and diseases, in one of the articles I found a quote that kind of sums up the advantages of urban tree diversity. The quote comes from the article. It says, "The benefits of a diverse urban forest are multiple and extend far beyond the functional reasons of stability." This goes back to aesthetics, enhanced quality of life. Many in an article that I had, many were surveyed. It was an article where people were surveyed, and they believe that urban tree diversity also brings a ambiance to the city itself. Those are some of those benefits that are extend far beyond the functional reasons. So the 10-20-30 rule, I believe, is and can be effective, but it varies from climate to climate and region to region, and there is certainly room for more research that could be done in order to fully implement this in different ways. So this was my presentation on the 10-20-30 rule. These are the sources I used for this presentation. Thanks for listening.